students, let us see the internal architecture of 8086 microprocessor. So this 8086 is a 40 pin IC. I already said it is a 40 pin IC. So that IC is what is the architecture that is present, internal architecture that is present in that IC. Let us see. So this internal architecture, that is a 40 pin IC, divided into two independent, so this you have to be remember, two independent functional units. The complete that IC is divided internally with two functional units, and they are bus interface unit, and next is execution unit. Okay, so the internal architecture of 8086 is divided into two functional units. One is a bus interface unit and next is the execution unit. So this itself is saying execution unit means it is executing something. Whatever the information that is the user is sending, that is executed by the execution unit. Okay, this is clear. And what is a bus interface unit? Interface means acting as a mediator. From where to where? From this execution part to external devices, means just like RAM, ROM and input output device, everything acts as a bridge between the outer devices and to the processor. So this the chip, whatever that 40 pin chip is there, this 40 pin chip, some part it is used for the execution and another part is used for bus interface unit to transfer the data. It's a communication. Okay, so this, let us see the bus interface unit. Bus interface unit. So first let me explain about the bus interface unit. So what is the use of the bus interface unit? What it does? What are the functions that this bus interface unit is having? Let us see the functions. So the first, the bus interface unit, fetch the instruction, means taking the instructions. Fetch the instructions or data from memory. Okay, the processor wants to execute something. So it wants to execute, it has to fetch the data, which is the user is interrupting. User is asking the some queries. So the processor has to execute that. To execute that information, the processor needs to fetch the instruction or data from memory through this bus interface unit. So actually this is present inside the processor only. So the execution unit wants to execute some data. So what data it has to execute? That data will be fetched by the bus interface unit. So the first function of bus interface unit is to fetch the instruction or data from memory. Okay, it fetch the data. So next, it write the data to memory. Okay, it's also doing another work like, so it is fetching the data from where? From memory or IO. So this bus interface unit is fetching the data, execution unit. So this completely in the processor. The processor is divided into bus interface unit and the execution unit. So first the bus interface unit fetch the data from memory and IO and send that data to the execution unit. So after that it performs some operation. The execution unit will perform some operation and send the data to the bus interface unit. Then what this bus interface unit will do? It write the data to memory. Means this is a result. This is a query. Okay. So after performing the operation, the execution unit will send that information to bus interface unit. Then the role of the bus interface unit is to write the data to memory. It fetch the data, at the same time it write the data to memory. Okay. And next, and it also write the data to ports also. Ports is nothing but input output ports. So it is sending the data to memory as well as to the input output ports. And also it does the work as it reads data from ports. So this is a simple information. The bus interface unit is always taking and giving, that's it. So from where it is taking, it's fetching the data from memory. After that, it write the data to memory, and also it write the data to input output ports, and also it read the data from ports. Means the fetch the data from ports. Fetch the data from ports and memory, and write the data to ports and to memory. So that is the work of the bus interface unit. So the bus interface unit consists of three functional parts. So that this unit is divided into three functional parts. We had seen the functions. So which devices is doing these functions in the bus interface unit? That is this, the functional parts. So these three functional parts will do these four works. Those are instruction pointer IP, and segment register, next instruction queue. So these are the three functional units which perform these operations. Means these operations will be divided in three functional units: instruction pointer, segment register, instruction queue. First, let me explain about these functional parts. After that, I will show you this operation in the diagram. Okay, so let's explain the instruction pointer. So what is the use of instruction pointer in the bus interface unit? So the first functional part is instruction pointer. So what is the role of instruction pointer? So the instruction pointer, first it is a 16-bit. It is a 16-bit register. So instruction pointer itself is a register. Everything, the data is stored and sent, everything will be done with the help of only registers. So you have to talk about the registers. Whenever you are sending the data and retrieving the data and doing the operation, means everything will be based on the registers. Okay. So in the registers, you are having the data in the form of bits. Don't be confused. Registers holds the data. That data is everything in the form of bits. So instruction pointer is a 16-bit register that keeps the address of memory location of coming instruction to be executed. Coming instruction to be executed. That is the role of this instruction pointer. So the instruction pointer, first it is a 16-bit register. What is the operation that this instruction pointer will do? This register will keep the address of memory location. Only it holds the address of memory location of coming instruction to be executed. Address of the next instruction to be executed. So this instruction pointer holds the address of the next instruction to be executed. So that is the instruction pointer. Next is a segment register. So second one is the segment registers that are present in the bus interface unit. So what is the role of the segment register? Here the memory space that is a 1 megabyte. I already said in the features that 8086 is having the addressing capacity as 1 megabyte. So this segment register holds 1 megabyte of memory of 8086 is segmented, means divided. Segmented means divided into 4 blocks. Each block specified by register with the maximum size 64 kilobyte. Means the complete segment registers is divided into 4 blocks. Okay. this is completely 1 megabyte. So 1 megabyte register. So here in each block specified with the registers. So the 4 segments are the code segment. Let me write that. The 4 registers that are used in the segment register: code segment, data segment, stack segment, and extra segment. Extra segment. So this is a code segment, data segment, stack segment, extra segment. So this completely of 1 megabyte. But each segment, code segment, data segment, stack segment, extra segment, is divided into 4 blocks. Each block holds 64 kilobytes of memory. Each register, so this you call it as a registers to store the data. So each can hold 64 kilobytes of data at a time. So up to 64 kilobytes it can store. So this is about the segment register. So the next register is the next functional unit is, that is the third one. This is instruction queue. Instruction queue. So the bus interface unit is divided into 3 functional parts. So one is the instruction pointer, which holds the address of the next instruction. Segment register is having the 4 segment to store the data. And next is the instruction queue. What is the role of the instruction queue? So here the bus interface unit performs its operation in parallel with execution unit. So the bus interface unit, it performs its operations. So whatever the operations it is performing is parallel with execution unit. And here the bus interface unit fetches instruction byte. First it fetches instruction byte while execution. So while execution it fetches the instruction byte is executing operations. Bus interface unit fetches instruction byte while execution unit is executing operations. Next, the prefetched bus, the prefetched instruction is saved in group of high speed registers and is known as instruction queue. Instruction queue. So what this instruction queue will do? First, the bus interface unit fetches instruction byte while execution unit is executing operation. So whatever the execution unit is executed the data, that is fetched to the bus interface unit with the help of instruction queue. And the prefetched instructions, so whatever to be executed, okay, so that prefetched instruction is saved in a group of high speed registers is known as instruction queue. So the instruction queue is there. So each instruction is having the 6 bytes. So each instruction will store, there is a prefetched instruction that has to be executed by the execution unit. That prefetched instructions is saved in a group of high speed registers. So this instruction queue is a high speed register that you have to be noted. Okay, that is saved in this instruction queue. So let's see the diagram, internal architecture. So this is 8086 architecture. So I said that 8086 architecture is divided into 2 units. One is the bus interface unit and next is the execution unit. So I already talked about the bus interface unit. So let me clear the functions that this bus interface unit will do. So I said the bus interface is divided into 3 functional parts. Okay, 3 functional parts. So what are those? So the functional parts, the 3 functional parts are the instruction queue. Okay, so here what is the instruction queue? This is the instruction queue, instruction queue, instruction pointer. Okay, so this instruction pointer, and next is the segment register. So these are the segment register. Okay, and this is the instruction pointer. So here, so the bus interface unit fetches the data from memory interface. Okay, and that data is stored in segment registers. Each register is having whole 64 kilobytes of memory. So total this is 1 megabyte. So each register is used to hold the data, whatever to be executed and whatever to be whatever already executed. And this is an instruction stream byte queue. So total 6 bytes are there. Okay, so this bytes will store next to what data has to be sent, that is in the form of a queue, one after the other. First one, so based on the priority condition, this will be stored in the instruction queue. Okay, so this is about the bus interface unit. So the bus interface unit is only fetches the instructions or data and send the instructions or data to port and memories, and get the data, read the data from memory and the ports. So in the next video, I'll explain about the execution unit. Thank you.